Hello all, I am Dr. Prafulla Bharat Bafna. I am presenting in front of you a customer's experience about the Starbucks, and the research study name is Analytical Study of Starbucks Using Clustering. In introduction, we can see the points as customer experience, target audience, sales of the company, clustering technique in Starbucks. So let's start with the customer experience. So whenever we are thinking about the customer experience, we are thinking about the how customer gives major contribution to both long-term loyalty sales. In many ways, the customer's experience is important, and customer experience is technically separate from the actual investment of the product or service. So here we are implementing Starbucks growth strategy. Starbucks implements corporate social responsibility, in which we are talking about the target audience. Sales of the company is a really important matter, and customer experience and sales of the company are related with each other. To increase the sales, the customer experience, better customer experience of course helps. So to study these strategies to produce decisions like where to have the location of the Starbucks or any of the company or industry, it's necessary to have some technique to decide that the location that you choose is important, and it definitely affects your business, right? So factors in what competitors and other businesses are nearby, this makes the final decision. And that's why we have used clustering techniques, that is hierarchical clustering and k-means clustering, in which we are going to talk about how depending upon the addresses of existing Starbucks, how the clustering is being done, and then based on that, where there is need of having new location of Starbucks. And then we have talked about the Starbucks location prediction, and then for this prediction we have also used performance evaluation. Now, how we have come to this problem, or what were challenges in the literature review? First of all, whenever we got that data, the data was completely unlabeled, and it was not having any type of prerequisites or information, and that's why we have decided to use the clustering. Location of the newly introduced store is not so much addressed problem for Starbucks, and that's why we have chosen this. And after all, we need to specify, or we need to validate our results, and that's why we have chosen performance evaluation with using silhouettes coefficient and other parameters. Yeah. So in research methodology, we have collected the data, then we have applied the clustering. As I have already told, we have applied k-means clustering and hierarchical clustering, and then we have performed evaluation of both of the clustering, and then we have came up to the result that which clustering is better. So in data collection, we were having store number, street address, city, state, and country. These stores were located in 3 different areas, which are known as 3 different types, and there were different cities, states, and countries in which the data was present. Now pre-processing is being done on the data, because hierarchical and k-means clustering operates only on the numerical data, and that's why we have applied the data into the numerical form. So here you can see the result of k-means clustering, where you can see here that k-means data set size is varying from 10 to 50. You can see here the entropy, purity, silhouette coefficient value for k-means and hierarchical clustering algorithm. So for data set size 10, the entropy is 0.11 and purity is 0.8, and even for data set size 50, the entropy is 0.1 and purity is 0.7. The minimum entropy is the better clustering, the maximum purity is the better clustering. So where we get the combination where entropy is minimum and purity maximum, we can say that that type of clustering is better. Silhouette's coefficient shows you the aggregate distance between the clusters and how your clusters are better with respect to the distance metrics. And that's why this 0.74 indicates that the silhouette's coefficient is greater than 0.5. And even for hierarchical accelerometric clustering, it indicates that silhouette's coefficient is 0.6. According to the literature, the silhouette's coefficient, if it is greater than 0.5, then it is assumed to be better clustering. In our case, it is greater than 0.5. But if you compare k-means and hierarchical clustering, then k-means gives better silhouette's coefficient. It means better clustering. So k-means works better. The takeaway of this table, I can say that as the size is increased from 10 to 50, for size 10 also and 50 also, the performance evaluation matrix is stable. So it has not happened that even for size 50, the performance is not good or it is being degraded. So that is for showing this performance consistency, this table is being interpreted. Now, as I am saying that clustering is being applied hierarchical and k-means. So here you can see for data set size 30, there are 3 clusters based on the 3 locations, and you can see here that these 3 clusters are having these many data elements. So if you see here, this cluster is having less data elements, so you can put here one more store, or this could be the area where the location of the Starbucks can be predicted. As I have told that silhouette's plot is also one of the evaluation measure, and if it is greater than 0.5, then you can say that the silhouette's plot is better. And that's why in this silhouette's plot you can see that the value is 0.64 as it is showing here. I have written it here also. So value is 0.64 and it is for the 30 records. So the records that we have taken in the earlier slide, for the same records, the silhouette's plots can be this silhouette's plot is drawn, and you can see here that silhouette's plot, it is showing cluster wise width. So for cluster 1 the width is 0.70, for cluster 2 the width is 0.68. Likewise for 3 cluster it shows its different width, and then the average of the width can be taken. There are different parameters which are set for the clustering. So you can see here cluster width, that is how many members are there in the cluster. Cluster withinness, that is these 3 clusters are having some distances within those points. So these distances are being mentioned, that is average of the distances is being mentioned. Betweenness is distance between the clusters, and total withinness is nothing but the sum of these 3 withinness. So if you sum up this is 4 plus 5 9 plus 4 13.33. the sizes are 333, and in 2 iterations this clustering is being done. So the conclusions of this particular research study is the location of the newly introduced store is being proposed by this method. We have taken 2 algorithms, k-means clustering and hierarchical clustering, in which k-means works better, in which it shows purity as 0.7 and entropy as 0.1. And the future work of our research study, it focuses on increasing size of the data set as well as different types of algorithms. So just now we have just tried 2 algorithms and we have increased size up to 50. So you have seen in the PPT that the size was from 10 to 50. So for the same size, like for the same experiment where we need to know the address of the store, the different dataset size will be taken, and dataset size will be increased, and even it will be tried for different algorithms. So that's it from my side. Thank you so much. I will just show you the references and then I will stop. These are the references which I have used for the study. Thank you.